Hi, I'm John Allen, President and Founder of Product Safety Consulting. Our business is to help manufacturers obtain the safety approvals, the UL mark, CE mark in Europe, the CCC mark in China. Basically anywhere in the world you need to go for certifications, we can help you. We have a full test lab and over 10 technical people to help all of your needs. Today's video is about helping explain the difference between the UL listing mark and that backwards UR, recognized component mark. And we're also going to do a little bit deeper dive into the UL database and how it can help designers design their products so the products pass first time through. So today's video, we're going to help explain the difference between the UL listing mark, which is the UL in the circle, and the recognized component mark, which is that backwards UR that everyone keeps asking me about. The UL in the circle mark means it's listed. The term listed to us in the compliance world means it's for an end product, a computer, a TV, a lighting fixture. The backwards UR is recognized component. It's a component of the system. It's a switch, it's a fuse holder, it's a terminal block. Those are recognized components. All recognized components come with conditions of acceptability. We call them C of A's. The electrical ratings, maybe it's an open servo drive that needs an enclosure to be considered a standalone product. Those are conditions of acceptability. If I heard this phrase, all my components are UL, so I gotta be good, I'm gonna get UL. I've heard that countless and countless times. And for the most part, that's correct, but like a bad example of a C of A for a switch and where that doesn't work. Let's say you've got a UL recognized component switch that's rated 2 amps. If you put it in a 5 amp circuit, that's not acceptable even though the switch is UL. It's only been tested to 2 amps. So you have to use it within the conditions of acceptability, C of A's. For polymeric enclosures, the biggest C of A is the relative temperature index, the RTI. It has a temperature limit. If you exceed that temperature limit, even though the material is UL, it's not going to be accepted in your end product. So what I'd like to do is actually show you an example of a C of A, condition of acceptability. Here we go. This should open. There we go. So this is a report actually from the manufacturer, from the supplier, that any supplier should be able to give you. This is confidential information, but if they're your supplier, you need to know these C of A's as a designer. And I'm scrolling through it quickly, but you can see here's the engineering conditions of acceptability. This is a report that UL puts together for this particular file. Here you can see one of the C of A's is production line testing has to be done. Electric strength, that's actually the C of A for all products. End product electric strength test must be done. So when you if you were using this power supply, when you install it in your product, the end product, your product, has to be tested for electric strength. Very common test, by the way. Secondary outputs are non-hazardous. So your output circuits for this power supply cannot be higher than SELV. Again, a whole nother video for you. I'm just trying to explain the C of A's. Here's a good one. The investigation is pollution degree is 2. Again, in a whole other video on the pollution degrees, but you have to comply with certain pollution degrees. If your end product is in a pollution degree 3, which is more severe than 2, you can't use this power supply. So as a designer, you have to know these C of A's. The printed wiring board is rated 130. When we do the temperature testing on your end product, we're going to put a thermocouple on the printed wiring board of that power supply. And if it exceeds 130, it's not going to be acceptable, even though that power supply is in fact a UL recognized component. So these are the C of A's that you should be able to get very easily from your supplier. So the last thing I'd like to show you is actually what I consider the most important part of this whole video, is UL's database and their certification directory. Let's go to ul.com, scroll down almost all the way down to the bottom. You can see their online certification directory. This has got to be one of the most useful tools a designer can have in his bag of tricks. Once you understand UL categories, you can search company name, city, all different kinds, keywords, lighting, switches. If you need to find a supplier, you can find it here. We're going to look, because I know this already, QMFZ2. We're going to look at plastics to show you more of what I'm talking about, the C of A's. So when you're looking for a material, and you can see there's 284 pages of manufacturers that have UL certification on plastic. A lot of end products have a plastic enclosure. As a designer, you need to know what those C of A's are before you actually start cutting steel for that material. Because if you pick a wrong material, you're going to have to rework your tooling. Again, time and money to market, right? So let's just take a look at 3M, big company, of course. So here, let's say you chose this plastic material, this polyethylene PET film, let's say you're using 602. So the color is no color. So that means all colors for 602 are UL with a minimum thickness of 0.01. Obviously it's a film, but here's a C of A, 105 degrees C relative temperature index. So if in your end product testing during the temperature test, we're going to put a thermocouple on that film. If we get over 105, it's not going to be any good. Here's another one, Scotch Cast 984 HF. PUR, I'm not sure, polyurethane. For this particular one, let's say the thickness of this enclosure, your enclosure, is 1.6 millimeters. But let's say it's black. Let's say it's white. Well, this is only black is covered for this material at that thickness with this flame rating. Again, C of A's. You would have to go to this one. You have a white enclosure. You're 1.9 to 2 millimeters thick. So if you're 1.5, again, this material is not good for you. You can only use the black. But let's say you've got 2 millimeter thick. Your flame rating is V0. Most standards require minimum V2. If your standard does require minimum V2, V0 is better than V2. This would be acceptable. But again, RTI, temperature, relative temperature index, 155. During the temperature test, we're going to put a thermocouple on the enclosure. If it measures during our test in your end product more than 155 degrees C, it's not acceptable. There is so much useful information on this database from a designer standpoint. Make sure you understand it. If you need help with it or anything that we talked about today, give me a call, send us an email. We'd love to help you out with your certifications.